Welcome everybody. So we're doing college algebra and we're kind of doing a prerequisite stuff. We're going to talk about input, output, domain, and range, how to write them and what they are. Um, so let's kind of jump right into it. So it wants us to fill out the table and then graph, but I'm actually going to start with the graph, y equals x squared minus 1. I'm going to jump over to Desmos, and as you can see here, y equals x squared minus 1. That's this red graph right here. So I'm going to go ahead and graph this on my graph. Keep in mind that these aren't going by ones. As you can see, this is 2. This is going by 0.5 or halves. So it's a half, then 1, then a half, then 2. So this is at 1. This one's at 1. If I go down, that's at negative 1. So those are important points when I do my graph. I'm going to go ahead and get out. I'm going to put a dot at negative 1, 1, and then down here on the y-axis, negative 1. And I'm going to try to draw this as best as I can. Just a basic rough sketch. I'm going to be jumping to Desmos when I actually analyze, so this is pretty much what I see. And now let's go in and fill out this table. So keep in mind, this is our x-axis, this is what we're going to plug in, and this is our output, this is what we want to find. So when we start off, this first one is asking if I put in negative 2 for x, where am I on the y? So if I plug in negative 2 over here, where is he on the y-axis? So let's go to the actual one that was graphed the best. I'm going to come over here. Here's my negative 2 for the x. And then I go up all the way to here, and that is where it lands on the y. So as you can see this point, it says negative 3. So negative 2 is my x. That's what I plugged in. And what I got out was a 3. So my answer is 3 for this one. I'm also going to do these ones. Kind of practice that. So if I looked at the x, where am I on the y? If I looked at 2, where am I on the y? So I'm going to come over here. If I look at 1, that's this one. And as you can see, I can point that. This is the x of 1 that I want. Where am I on my y? Well, he's at 0 for y. So I can come here and say, well, he would be at 0. And then I can come back over here, set off. And then the other one was 2. I go up, click on that one, and I can see that if I'm at 2, I'm all the way up at 3. Sorry. Gotta get it right. So at 2, my y value would be 3. Okay, let's put that down. Hopefully you saw that. Sorry about it jumping around. All right, it's a little trickier going backwards because it's so much easier doing input or the x values because we're used to our x line more. But now we're going to look at our y's. So when we're looking at this, it's saying, okay, when y is at 0, so here's it at 6, 5, 4, 3, 2, 1. When he's at 0, where's the x's? Well, actually, if we look at it, I can kind of see on my graph I drew here, I have 2. He's there, and then he's there. Both those points are at 0. So it's going to give me 2 answers. So I'm going to look at Desmos, get a kind of clearer view. Here's the 0 for y, and I go over to my graph to figure out what the x would be, and I can see x would be at 1. But there's another one here that also has a 0 for y. So both of those, notice the second number is 0. So the first number, 1 and negative 1, what that means is I have 2 answers. I can have 1 or I could have negative 1. Either one of those, the graph will be at 0. So now this is asking when would it be at negative 1? Remember, we're not talking about x. So we're not talking about being here at negative 1. We're talking about the y. So if I'm on this line and I go down to negative 1, so I just keep drawing. Down here, there's negative 1. I can see it right here. My y is at negative 1. That means my x must be at 0. So you can use Desmos to kind of fill in that table, but you want to look at the graph and then find where whatever variable you're looking for falls. All right, so this is kind of how you've been doing it, hopefully when you were in the lower levels, and it was kind of review. But we're going to talk about now writing our notations, and we want to start calling them x's and y's. We're going to call them inputs and domains or outputs and ranges. So you really need to kind of change your terminology. It's still the same thing. X is still x. It's just instead of calling him x, we're going to call him input. Instead of calling it y, we're going to call it output. If I plugged in input, a negative 2, I get out a 3. All right. Same goes with the domain and range. It's just another name for our x value. So x would be domain.
and y's would be range. So you kind of want to get this in your head. You want to stop saying x and y's. You want to say input, output. The other thing that you really want to make note of is your functional notation. You're going to see this. We don't write y anymore. Y kind of switches around. You're now going to say f of x. It could be h of x. It could be g of a. It could be t of c. It could be all of this when we're dealing with story problems. Keep in mind that we're talking about a y. All right, so that's all it is. So instead of calling this y, they'll call this t of c, and they'll call this the c. When you're doing this, kind of my mental note that helps me is if you're using two variables, f and an x, h and an x, g and an a, t and a c, you're talking about the y. If you're using one variable, that's this guy that's inside the parentheses. So whenever I want to identify them, this one would be x, this one would be x, this would be a, and this would be c. Either way, all they're doing is just labeling this differently. Instead of calling it x, they might call it a, or they might call it c. And up here, they might call this f of x. They call that the h of x. They could call that the g of a, or the t of c, based on whatever the story problem needs. So just know that they're going to write those x's and y's differently now. And we kind of talked about that, input and output. Input is just your x values, output is your y values. Domain are the x's and the ranges are the y's. Do make note that when you do domain and range, you do not repeat, I'll get there, the same number. So you don't repeat the same number. And you're going to see some of those. So let's get into actually writing this. Get Molman out of spelling here. All right. So again, we're going to see data in multiple ways. If we see it as ordered pairs, or pairs like this, not graphed, but actually kind of like this, the easiest way to do this is I'm going to highlight. Actually, let's start off. We have our axes, and you're going to want to start kind of writing this format so you start getting it into your head. X is going to be our input values. He is also called our domain. I am leaving a little bit of room. You'll see why, because we're going to write underneath it. All right. So these are kind of his titles we work with. Now we're going to look at the points. So I'm going to come to these ordered pairs. The x's are the numbers that are in the front of each parentheses. So those are my x values. And then if I asked you, like, what is the input, you would just write down those values. There are 2, -3, 5, and -2. When you do domain, though, the way you write domain is actually D, semicolon, this kind of funky grouping symbol, and then you want to write it from the lowest to the highest. So if you're looking at your input, the lowest number here is -3. My next lowest number is -2. My next one would be 2, and then my biggest one is 5. All right. When we talk about those y's, we no longer call him y, we call him an output. And he's our range. So notice they're the same numbers, they're just written differently based on whether I said output or domain. All right, so the output, I'm going to make that pink, are the second numbers in every one of these parentheses. Each one of those are the outputs. So again, when we're writing them, you can write them as you see them when we just say output. So 3, 4, 6, -3. Those are the outputs of each of these sets of data. When we write the range, we're going to do, instead of a D, we'll say R, because D for domain, R for range. We get our little grouping symbol. And again, we want to go smallest to largest. Now be careful, we don't repeat the same number, but 3 and -3 are not the same number. -3 means you owe money to somebody, and +3 means you have money. That's two different things. So our lowest number is -3. Our next number is a +3, then 4 and 6. None of those numbers really repeat. All right. You could also see the data in a table. It's all the same thing. I want you guys to keep writing it like this, just so we can start getting this into our head. The more you write it, the more it'll be in your head. So X just means input, and he also represents our domain. Right? You can even go here and say, well, if I'm going to do domain, I know it's going to be dot like that. It's going to start off. All right, let's go ahead and highlight our domain or all our X values. And since I have the highlighter open, these are my Y values. So if they're in a table, they're kind of listed for you. When they ask you for the input, you just have to write down the input. You don't have to worry about order or repeating anything. You're just telling me what they are. And then the domain has to be in order. And these are actually in order. It's kind of nice. -3, -2, +2. Jumping over to the Y or the output. I'm going to write this down as fast as possible. And range, because we have a couple that are a lot harder than this. So hopefully this stuff is not a problem for you. All right. So kind of coming here to our purple. Output, I'm just going to put, however I see it, it's 4, -3, and 3. But when I do the range, I do have to put it in order. -3 is technically the lowest one, so I'll put him first. Then 3, and finally 4 is our biggest number. So there's it in points or on a table. So we're going to kind of jump into graphs. I wish I kind of did the last problem first, but that's fine. We'll go back to it. So we're starting here. This is still discrete. Remember, these lines are not connected. These are their own little individual dots. So that's important to make note of that we have 4 dots, right? They're not connected with a line. And for me, it's easier if they're given to me in discrete to just say where these dots are located. So this one is located at -1, 2. That's this first dot. This other dot up here is at +1, 2. It doesn't matter which one you say first, just so you know. This dot in the middle is at 0, 0. And this one down here is actually at 0, -2. So remember, we say the X, and then we say the Y. So we get those points up. To me, it's easier just to do it in the point format. They're just showing on the graph. So, whoops. So our pink is technically our Y's. Let's get those highlighted correctly. So the Y's are the second number, and the first numbers are all of my X values. And then I'm going to go ahead and start doing now. Okay. So we have our input. We have our domain. I'm getting the format down. That's the D, double the semicolons, get that little line up there. And then I just say the yellows. So it starts off with -1, and then it goes to 1, and then 0. And notice 0 happens twice. I'm going to write him twice here. That doesn't matter if they just ask you input, but when they do domain, I am not going to write it twice. So when I come here, my lowest number is -1. My next number is 0. Yes, he happens twice. I don't care. I'm only going to write him once, and then I put 1. So domain is not telling you how many times you see something. It's just the numbers you see. All right, brings us to our output, also called range. Get the R. Again, this is all just formatting. And this is all of our pink numbers. And I can look here, I got 2202, or 220 -2. So I'll get there. So we have 2. And this order doesn't matter as long as I just get all of the numbers that are there up here. So I put them out of order this time for you guys. Range, when you do range, that's when order matters. So I come here, the lowest number is -2. I go to put -2. The next lowest number is 0. I'll put 0. And again, I notice I have 2 2s for these ones. I'm only going to write him once though. It doesn't tell me how many times I see something. It just tells me what I see. All right, so those are kind of the easier ones. Those are discrete data, meaning that we're just looking at points, whether they're given into a table or a graph or just right now. Getting into a little bit harder. This is called continuous. These dots are connected. There's a line. I can see the W. It's all connected, which means I can't just list them off because every one of the dots in between, there's no way for me to write all of them. So we're going to write them a little different. We're also going to start off the same. we're going to say our x's are our input, and they're also called domain. Now, because they are connected, I'm not going to write these things twice. I'm just going to do the domain. So d dot, you'll see this. If you just ask the input, you just put whatever you put inside here would just be called the input. If you have it in this format, you're saying domain. But keep in mind, it's the same thing. Nothing's different. All right, so domain are all of our x values. So when I look at that, that basically means how far left does this graph go and how far right does this graph go. So that's what I'm looking at. So if I looked at this W and I was like drawing a line, I'd say this right here is the furthest left this graph goes. It does not go any further. There's nothing over here on this side. And if I look at this, this is as far right as it goes. Everything else doesn't exist. There's nothing over here. So this, in between here and here, all the values fall for x, nothing else. So when I write it, I'm going to start with my lowest one. So I come over here and I count. I say, okay, well, if I'm on the x, that's out. 1, 2, 3. So I come here and say that would be at -3. That's the furthest that it goes this way. And the furthest that it goes this way is 1, 2, 3, 4. Now to write this, we're going to put this little inequality sign with the x. We're saying x because x goes with domain, right? And then we're going to put this little inequality sign. Remember, we want to have them facing this direction because you want every number bigger than -3 because he's on the right of it. And you want every number smaller than 4 because it's on the left of this side. So, but if you get used to writing it in this way and you don't change it, and you always put the smallest to the largest, it'll always stay in these directions, which is kind of helpful. All right, let's talk about range. So remember, range is also called output. And I'm going to put the format R. This stays the same. The difference is instead of saying X, we're talking about Y's. Other than that, this stuff, these little inequality symbols, they're going to be there. So I can literally set up the format like this before I start talking about it. I'm going to go ahead and erase the domain off of here. The range is me going high and low. So I want to see the bottom of my graph, which is here. If I cut the paper, it'd be there. And the top of my W, which is here. So this is at, let's go here, 1, 2, 3. This is at 1, 2. If I look at this, this is where all of my range falls. So the lowest number is -3, and I can just plug that in. The highest number is 2. So that's kind of how you do domain and range when you have a continuous function. So let's talk about some of those continuous functions that maybe they don't end. They go on forever and how those look. So here's one example. You can have them going on forever in all directions, but here's one of them. The more you practice, the better. Starting off with our x, our domain, which is, again, we just write this up here. It's the same stuff, input, output, and it's the domain with the double dots. And I know that I'm going to have those inequality symbols because it's not dots, it's actually connected. There's a line. The dots are all basically connected. So I know that I have a domain that's going to end up looking in this format. Now, all I have to do is plug in the numbers. So I look at my graph now, and remember, that's going left to right, not up and down. So if I go to the left, here's the furthest left he goes. Go down here. So I'm going to count down here. This is 1, 2, 3, 4, 5, 6. I'm going to call this -6. And then, but if I go to the right, if we can see, this has an arrow. This means it's going to keep going up and up and up. So even if the reason it stopped is because I just ran out of room, but if I keep going, there's going to be a point here that it would connect to. And then it would just keep doing this over and over. I could go further and further and further and further to the right. He's never going to stop. He's just going to keep going up that way. So what that means is he goes on forever. And our number that says goes on forever is infinity. So this would be -6. And this side to the right, he doesn't stop. He's just going to go on. so I don't have a number. All right, range, that's us going bottom to top. Sorry for my penmanship. Again, I like to get the format down. It's just easier for me. I don't forget anything. Instead of X, we switch to Y. Other than that, those symbols stay the same. So now I look at the bottom, that's here, nothing goes below that. But as we see, that wonderful little arrow means he's going to keep going up too. We already saw it go all the way up here. So he's going to go on forever up top here. But he does stop down here. So let's count that. That's 1, 2, 3, 4, 5, 6. I think that's -7. So he does go to the bottom of -7, but then he goes on forever up top. And that infinity can go either way. Just know that like this graph is going up, but you can have graphs that go down, and then this side would be the forever instead of the other side. All right, so those are kind of domain and range. You could see input-output tables in their bubble format. As I said, I kind of wish I would have put this up with the other ones because honestly, for me, I actually just write them out in their point format. I don't look at the table and do things. I'm better when I look at points because I know the first number is the X values and I know the second number are the Y values. So let's go ahead and write these as points. So this is an input, the first one. That one is an output. How I can tell that is the arrows. So this starts at 2 and then goes to 3. This starts at 2 and goes to 0. This starts at 3 and goes to 5. What that means is if I plug in 2, I get 3. If I plug in 2, I get 0. So those are the points. We have 2, 3. The other point is 2, 0. And our last point is 3, 5. And then, as I said, the rest of this is exactly what we did before, where we go, okay, well, this isn't continuous. So if it's not continuous, we can just write up the points. We don't need to worry about the inequality stuff. So we can turn around here. Sorry. And our input values here are 2, 2, and 3. Domain always has its format. And again, I don't repeat numbers, so that would just be a 2 and a 3. And then our range are our output and range. I just write them down as well. So that's 305. And then the format for range, I kind of drew in my area, so I'll just put it over here. I do put them from lowest to highest. Parentheses there. But other than that, it's the same thing. It's easier for me if I put them in points, so I would suggest putting them in points. All right, guys. Well, I wish you luck. Hopefully you can get this stuff done.